So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now, thinking back about the safety issues that I've encountered in the solar industry over the past 20 or so years, about 15 years ago, the solar and the fire industries got together to improve the safety of the rooftop solar panels. It resulted in some setback issues. It kind of slowed things down, limited roof space, but good accommodations were made. Now, the solar and the fire industries are working together to ensure that lithium-ion batteries are installed and operated safely. Now, I got to just back up one sec here. The most important safety issue in the solar industry is making sure that the workers are tied in and safe and following OSHA procedures. But right now, lithium-ion battery safety is kind of top of the mind. So here's the issue. Anything that stores energy can be dangerous if that energy is released in an uncontrolled way, like a fire or an explosion. I kind of was doing some research on the internet. The highest energy density on Earth is uranium at about 80 million megajoules per kilogram. An uncontrolled energy release of uranium is what we call an atomic bomb. Now, actually, antimatter has 1,000 times higher energy density than uranium, but of course, that's only on Star Trek, and you know what would happen if the warp engines on the Enterprise were to explode. So let's talk about something a little bit more practical and terrestrial. We use chemicals with high energy density here on Earth, especially for transportation. Now, those chemicals for 100 years have been gasoline or diesel, and it works really well because gasoline has an energy density of 46 megajoules per kilogram. Now, not as much as uranium or antimatter, but you can drive your car for 300 miles on a 10-gallon tank of gas that weighs only 65 or 70 pounds. That's pretty good. But fossil fuels are polluting. We have abundant, cheap solar and wind energy. That's the future, no doubt about it. But you can't drive your car with a solar panel or a windmill on your roof. It's just not going to get you more than a mile. So we need to store that wind and solar energy in some way, and that way is a battery. So we've been using lead-acid batteries for over 100 years, but the newest technology that works the best is lithium-ion batteries. And these batteries have energy densities of about 1 megajoule per kilogram. And 1/46 of what you've got with gas. But with a big battery, you can go pretty far. So a typical EV can go about 200 miles on a 75 kilowatt hour battery pack that weighs about 1,000 pounds. It's less mileage and a lot more weight than you get with gas, but it's a lot cleaner, and long term it's a lot cheaper. So now we're using lithium-ion batteries not only for vehicles, but we're using it for stationary energy storage. That's for batteries in a home or a business, or utilities are using them. And they're great to use, and they're cleaner instead of a generator. Also, a lot safer than gasoline generators or diesel generators. You think about lithium-ion batteries, they're everywhere. They're in my phone, they're in my earpiece, they're in our computers, they're in our cars, they're ubiquitous. But they're still subject to combustion if damaged, or even, fast combustion is kind of an explosion. So nevertheless, they are extremely safe. The track record is great. And the solar and the fire industries are working together to make sure that those battery installations are as safe as possible. So really, to talk about this, the expert in the country on this issue, his name is Matt Pace. He's a friend of mine. He's a technical advisor for battery materials and systems for the Pacific Northwest National Laboratory. There's like 30 of these national laboratories around the country. Matt's their expert on batteries. Previously, he provided consulting and training for fire and code officials, and he's a local guy. He's a retired fire captain in the San Jose Fire Department. So welcome to the show, Matt.
Thank you, Gary. Appreciate you inviting me.
All right, good. Tell us a bit about your fire protection background.
So my background in the fire service is really on the operations side, which means that I responded to 911 calls on an engine company and fought fires and medical calls. The fire prevention activities I've been involved in primarily were related to codes and standards, beginning with PV systems and then growing to energy storage systems as they expanded in popularity. I represented the International Association of Firefighters on a number of different codes and panels, NEC for a number of years, and now on energy storage product safety standards such as UL 9540 and NFPA's 855. So that's my primary activities with fire prevention, is helping draft codes and standards and then outreach to the users of the codes.
Okay, good. And you're at the Pacific Northwest National Lab. What was the focus of the lab there?
Right. So my role today is I'm a technical advisor in the Battery Materials and Systems Group. I'm at PNNL. And PNNL is one of the 17 DOE-funded national labs. And they're headquartered in Richland, Washington, southeastern Washington state. And like all the national labs, they focus on a number of different areas, from energy and environment to national security to nuclear safety. In the Energy and Environment Directorate where I work, PNNL is really focusing on modernizing the grid. And we have a lot of scientists that are working on developing the next generation battery materials to help, develop these into technologies that manufacturers can build systems and put them in the ground. But we do quite a bit of work on trying to come up with solutions to a variety of different grid challenges, from storage to detection of faults. Wildfire challenges are a big area the lab's really working on. But on the material side, we're trying to develop batteries that are higher density, lower cost, more reliable, and safer.
All right, cool. So let's dive right into it. What are some of the differences between batteries that are used in residential applications, for commercial applications, and in utility settings?
So at the basic level, they consist of the same cells. A residential system obviously is much smaller. A single unit will typically be less than 20 kilowatt hours. And homeowners could have one to many batteries, depending on how big of the house and what they need. But when you look at a residential battery versus a commercial batteries typically are used in light industrial to utility scale. And they could be large cabinets to 40-foot shipping containers to an entire building filled with racks of batteries, like we have down in Moss Landing, which is the largest battery in the world. That fills a 900-foot long 3-story building with close to 5,000 battery racks. So the commercial systems typically involved a lot more communications equipment and larger inverters to get up to the larger voltages needed, and typically environmental controls, HVAC. So a lot more equipment involved on the commercial side.
So let's kind of get a little bit more specific about the battery cells, the battery controls, and the enclosures. Talk to us a little bit about the designs of those major components.
Sure. So going back to that cell, the cell can be in typically 3 different formats. A cylindrical cell, which is what Tesla uses. You can think about a large AA battery or, like a C battery. It's round and has a rigid kind of case on it, metal case. The other type is what's called a prismatic battery. And think about your car battery. It's more of a square, rectangular shaped battery. And then the third one is a pouch cell battery. And that's what you have in your laptop or your cell phone. And so those are the formats of the cells. And then what happens is they're wired together into a module. So you got a certain voltage and current. And then those modules are stacked together to become what's typically called a unit on the residential side, or like a rack on a more commercial industrial side. And so that's the terminology that we use. Then the communications really involves a really important piece of equipment called a battery management system, BMS. And the job of the BMS is to monitor the voltage, current, and temperatures of those cells in a module or in a whole unit or a rack. And so that BMS is really a critical piece of safety component to make sure the battery is not charged too fast or too high of a voltage or discharged too low or too fast. And the BMS really is the key brains of a battery. And then if you have a system that has a number of different batteries, you might have an energy storage system manager, and that's taking the data from all of those BMSs and ensuring that all of the different either containers or enclosures are operating appropriately. And there might be some fire protection equipment on these larger systems, and also some components at the energy storage management system might communicate to. In the case of a utility or larger, all the data might be monitored off-site. And those are typically called SCADA facilities that are monitoring the controls. Well, even the residential systems communicating with the manufacturer or the integrator who installed it just to make sure that any alarms are noted by personnel. So there's communications even behind the scenes for a residential battery.
Okay, yeah, and communications is actually turning out to be a real challenge for us to do these installations. Let's kind of take a step forward. What are some of the safety issues that we've encountered with lithium-ion batteries, both in cars and also for stationary applications?
So lithium-ion batteries, just due to the nature that they have a flammable electrolyte, it's a small amount, but it is flammable. If that battery is heated too high through a number of different, either charged too fast or too high, what happens in the battery is it can overheat to a point to where that electrolyte starts to vaporize, and then through that pressure built up, it's ejected out of the cell. Because it's flammable, you have the potential for that to ignite. So that's a process called thermal runaway, where the cell is heating through an exothermic reaction faster than it can dissipate heat. And it can definitely incorporate flames or, at the very minimum, a lot of flammable gases. So the challenge is, how do we incorporate these cells and manage them so that if there is a failure of a cell, it doesn't propagate to the entire battery, which can be, pretty catastrophic. And so one of the things that is really important in these batteries is not only that they have gone through some testing, some fire testing to understand how to design the enclosure to protect against those failures, but also how best to install them. And so right now, the place that we're at in the residential market is, because of the codes and standards and requirements, they don't currently have to go through that fire testing. That's referenced in the fire codes. And in future codes, they will absolutely have to go through fire testing. But right now, it's a little bit of an awkward space for the residential market. And so we really want to see manufacturers, putting these products through fire testing ahead of when they're actually required, and to make sure that they're installed in an area that if there is a failure, the damage to the building will be at a very minimal amount. So the location of the battery is very important, and that is location dependent in the country as well. Obviously, an outdoor installation here in California is pretty easy, and it's a good environment. But in areas like Phoenix, that might not be a great idea. A garage in Phoenix might be a really bad idea, or outside in New England might be a bad idea just because of snow. So it's a delicate solution that has to be addressed location by location.
Yeah, really, from an installer standpoint, boy, I was at 2 jobs yesterday helping my team trying to figure out where we could put 2 batteries, and it's a challenge on a lot of homes. We've really, as an industry, have to make sure that it's done in a safe way, and also work with the manufacturers so that they package the batteries and the enclosures in ways that pass these building code tests that are going to ensure the safety. So kind of taking another step forward, what should customers look for when selecting a battery or a battery system?
So the first thing is to ensure that the battery that's being spec'd for their project, the company that's providing the bid for them provides cut sheets or data sheets for the battery that they're recommending. And homeowners should look at those cut sheets. And the first thing they should look for is to see that it is UL listed. And that listing is 9540. So that's the first thing, is to really ensure that it is listed. There are some challenges with kind of lesser known batteries. You want to ensure that it is a valid listing. There are always counterfeit issues. But that's a little more difficult for a homeowner to evaluate. But that's the first thing, is the listing. And then the other one is to ensure that the company that's installing it has experience installing batteries. This is still new for a lot of people, although it's growing pretty significantly. I think you found that a majority of your solar projects are being requested for batteries. So that's a good thing, because the solar contractors are gaining experience installing batteries. But it's the reputation of the installer, and that can be verified through either references that the company provides, or better yet, friends, neighbors that have had them installed. Reach out to them and ask them what their experience was with that installer. Were they responsive to questions that the homeowner had. Did they clean up after the job site? Did they do what appears to be high quality work? And that might not be apparent to all homeowners, but I think those references are really key. It does tell a lot about the professionalism and qualifications of an installer.
Yeah, that's what I always recommend to people looking for a system, regardless of where they are around the country, is just find an installer that's got good references. All right, so let's dive back into all these numbers here. You mentioned UL 9540. A lot of us in the industry are really challenged with something called UL 9540A. What is UL 9540A?
So 9540A is a test method for a large-scale fire test. And the purpose of that test method was to provide data for system designers to understand what fire protection systems might be required based on the installation. And what this test method does is it begins with the cell. And if the cell can be forced into thermal runaway with a heater applied to the cell, and if it produces flammable gas during that runaway, then that kind of forces a next level test of a module with a bunch of cells in them. And the goal is to force one or more cells in the thermal runaway to try and get it propagating thermal runaway within that module to understand how much gas might be produced if there is a fire inside a module. And then the next test that would be required is called a unit level test. And so on the residential battery, that would be the end test. And the idea is to understand if you might have any fire that comes out of the box or flammable gases that come out of the box. And what's done with that data is to understand either what's the smallest area this battery can be placed in if you don't get any fire that comes out of the box, or if you just get flammable gases. If you have fire that comes out of the box, on the residential batteries, the test actually requires that you don't have any fire that comes out of the box if the battery is going to be mounted on a wall. And that is very challenging for current lithium-ion technologies because they do often produce fire or flammable gas. So one thing that's really important to understand is the tests that are required are basically a function of the fire code. The fire code that California has adopted, the California Fire Code, it references different product standards. And when it references 9540, it references a certain edition that was available at the time that was written. So the California Fire Code that's in place today references the first edition of 9540. And within 9540, it does not require the 9540A fire test for residential batteries. And that goes back to what I said earlier. We're in a little bit of an awkward state. The second edition of 9540, which is published and was released in 2019, does require fire testing for all residential batteries mounted on walls. So California is not going to be referencing this until they adopt the 2024 International Fire Code. And so it's going to be a couple of years until that's in place here. But as manufacturers look to get products listed, they have to certify their new products to the current standard. So for new batteries coming on the market, they will get that certification. It's just the older batteries that are already in warehouses that might not have that fire testing. So kind of a long explanation there, but it's important that people understand that the batteries will be listed, but they may or may not have gone through fire testing.
All right. It's really a challenge and ironic when I talk to battery manufacturers because, they're complaining like, okay, we design our batteries so they never burn. But in order to pass the test, we need to heat them up with a fire to make them burn to see if they'll burn adjacent batteries. So, it's a challenge. It's expensive, but it really needs to get done. Tell me a little bit about the specific code requirements that are being mandated in a lot of California. I mean, we're experiencing it all over Silicon Valley. As far as separation of batteries from each other, like two batteries have to be separated, and any kind of separation from doors and windows, and the maximum number of batteries that you can install for home.
Sure. So Fire Code lays out requirements for siting of the batteries. And one that you mentioned is spacing. And it currently states that the batteries cannot be placed closer than 3 feet apart or within 3 feet of windows. Now, there's a caveat to that if based on that 9548 fire testing, it shows that you can place the batteries closer together, then the installer can do that. So part of the goal of the fire code language was really to create kind of a stringent requirement, but a pathway for less stringent based on how the battery performs in that fire testing. And so we're starting to see more batteries go through that fire testing and learning about them. And some batteries have shown that they can be placed closer together. And so that's proving to show that the goal of those standards is resulting in safer designs. And, we'll continue to see safer and safer designs. So while manufacturers really try and design a battery that can't catch fire, the current technology of lithium-ion cells, you really have to design for the worst case scenario. And that is a single cell that has an internal defect and just fails. So that's really what we're trying to identify is if you have something that it's not the battery management system that's preventing it from being overcharged. It just was a quality control issue with that cell. And we really want to make sure that it doesn't result in a catastrophic failure or explosion. So outside of that 3-foot spacing, there's also some requirements for spacing around windows. But, one area that the fire and life safety community has expressed some discomfort with is there currently is an allowance for a battery to be placed indoors in a garage or in a utility or storage space. And that utility and storage space is that one area that has some in the fire and life safety community concern, because it could be a very small space that perhaps opens up to a living room or a hallway or a kitchen. My house, my kind of utility room where a sub panel is in a laundry room that opens up into the dining and living room. So, that's an area where I think that installers really should very carefully evaluate whether or not that is the best and safest location. That was carved out for those residents that may not have a garage, perhaps a townhouse or something that they might have some homeowner association requirements that don't allow equipment on the outside. It also includes a basement too. So in those areas of the country that's the utility space, the code does require that it be a finished space. So you have to make sure that you have sheetrock protecting all of the structural members. That's an area that I think remains concern among those that are involved in the lithium-ion industry, that we are still fairly nascent in this industry. We've had some recalls from some manufacturers based on some fires. And even I think today I just read that GM is recalling more of their vehicles based on some fires. So it's still a problem. It has not been solved. And I think we need to just navigate this very carefully to ensure that customers feel comfortable with this technology.
Yeah, it's a high energy density product. It's safer than gasoline, but we park our cars in the garage. We have gas hot water heaters in the basement in the house, and all those are hazardous too. So I'm pretty happy right now with what I've seen anecdotally that the safety of lithium-ion batteries is safer than cars exploding or natural gas fires, but still, we want to bring it as close to zero as possible. Now, will these codes extend to other states, or what other states are you aware of that are starting to enforce these separation codes and living space codes?
So those are all cited in the two model fire codes that are used in the U.S. There's the International Fire Code and the NFPA 1 Fire Code. Those requirements are in both of those. And so as states adopt the most current edition, which currently is the 2021 edition, then those requirements will be laid out in there. So different states adopt at different cycles. So as an installer that installs across multiple states, they need to be aware of what state is on which version of the code and then follow those. One of the recommendations I have for manufacturers is to install to the most current requirements. A lot of those have best practices based on failures and fire data. And so, I keep a high bar of safety and, install to the most current requirements.
Yeah, we have that happen sometimes. A customer says, well, somebody else told me I can put it inside my garage. And we're like, well, we don't do that, or we really don't want to do that unless we take special precautions. Now, speaking of garages, can we use the batteries that are parked in our garage, our car batteries or our pickup truck batteries someday? Can we use those in our home, or how could we do that?
So we will in the very near future, and that's something called vehicle to grid, where the battery is both being charged by the grid and exporting to the grid, or just the house in the case of a backup. And we're even seeing one manufacturer market that for the Ford F-150 Lightning. So it's very exciting. Today, however, you're limited by a couple of different realities. One, the vehicle does need to provide what's called a bidirectional inverter. So the inverter that's on board the vehicle already to allow the AC power from the house to be converted to DC to charge the batteries would need to be able to reverse and send power back. And currently, there's only one vehicle in the U.S. that does that, and that's from Mitsubishi, the Leaf. But also the manufacturer needs to support it. And also today, Mitsubishi, while they do allow that, the clarity on their warranty is not as clear as we'd like to see it. So once that's worked out, there are some NEC requirements that we'll need to make sure that the vehicle is not backfeeding into a grid that might be damaged due to trees dropping or linemen working on the wires, and also that the safety requirements of sending power into the house are addressed. And so there's a lot of language that's being adopted into the National Electrical Code to kind of create this pathway. Everyone's working on it because it's definitely going to be needed use of energy storage. Vehicles can represent a real significant amount of energy storage for backup and to the grid as well as to a house. But it's definitely a very exciting area.
Yeah, no, it's exciting. And I was cracking up when I saw that commercial for the Mustang Mach-E around Christmas time where Clark Griswold, played by Chevy Chase in the Vacation Show, was plugging in his Christmas lights into his Mach-E. And certainly, I'd say the Mach-E's got like almost 100 kilowatt hour battery, so it could do that. But then you need a big inverter that's going to connect, and then also obviously the safety things that you talked about. So talking about solar and batteries at home, what kind of equipment do you have in your house?
So I've got two different systems. My first PV system was put in 2004, and they're 130 watt Kyocera modules. So the installers listening to the show, I've got 36 of them mounted to a retaining wall. And it's actually a pretty impressive installation. And I would say that almost 20 years later, that thing's probably still producing about 80% or so of its nameplate rating. So it's been upgraded a couple times with different inverters and components. Yeah, and I have a newer system.
Yeah, I just have to interject. Those KC130 solar panels were great. Kyocera was one of the very best companies I've ever worked with. And just a kind of an anecdote as far as how important it is to work with a good company. They originally were shipping KC120s. This is in 2001, 2002. And there was a fault with them, and they were defective. And Kyocera, the manufacturer, big manufacturer, said, we're going to give you brand new modules. They happen to be 130s, and we're going to pay for your retail rate to install those. And so whenever I see a KC130 out there, I'm pretty sure it was installed originally as a 120. But that was a really good module, and they just keep working. So good manufacturers for solar and good manufacturers for batteries are great. So sorry for interrupting, but I just like that.
No, that's fine. No, these actually were the original, the 130s. But it was, my friend who was installer, we worked out together, only installed these for many, many years because of that reliability of this manufacturer. So, you're absolutely right. But, I have another system with 350 watt modules, so a significant increase in size and power and efficiency. But I do not have a battery yet. I have a generator. I live up in the mountains, and so we do have power outages. I do actually have a pretty good outdoor location for a battery. I'm just kind of like a lot of consumers, looking for price to come down, and me being in the industry, I'm looking for, increases in safety and monitoring and controls. I do look to install some batteries, in the near future.
It's going to be ubiquitous. As I mentioned, very high percentage of our customers are interested in adding a battery or just call us exclusively for batteries. So, Matt, this was just a terrific show. I really appreciate your insights, and I hope everybody listens to the whole thing because there's just so much wisdom in this discussion, both for consumers and also manufacturers. So that's all the time we have on this week's Energy Show. And thanks to all of our listeners for tuning in. If you missed any of today's show, you can always go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.